Welcome to solverfy.
This is the answer to Chapter 27, problem number 14 from the Smith Organic Chemistry textbook. And we're asked to draw the products and predict the stereochemistries of each product for two 4+2 cycloadditions. And so remember, for thermal 4+2 cycloadditions, these have to be superficial because of the constraints imposed on the molecules by the fact that they are only forming six-membered rings. There can't really be any twisting, and so these need to occur only in a superficial way. And so the first thing to do in each of these instances is to redraw the dienes that were given. And so when we look at A, change my color. So when we look at A, we have this diene that we were given, and I have redrawn it like this just so that it's easier to see how these molecules are going to add to one another. Similarly for B, we're given this diene, and I've redrawn it there. And so looking at A, we can draw the way that these electrons are going to move. So we know this is a cycloaddition. It's a 4+2 cycloaddition. So new bond there. These electrons will move over, and these electrons will go to form the second new sigma bond that we're making. And so we know that we're going to end with a six-membered ring here. And so there is our six-membered ring. There's our double bond that we still have. And then, as we said, these are superficial reactions. So if we imagine the diene, the ethylene in this instance, coming from above, so if we remember, if we picture the dienophile, which in this case is the ethylene, coming from above the diene, these two methyl groups would be pushed down as it comes in, and so they're going to be cis to one another, and that's what we see here. So they're both of the double bonds in the starting diene are trans, and so they're going to be cis here. They move in the same fashion, so to say. So when we look at B, we see that the opposite is the case. So the top double bond is trans, the bottom double bond is cis. So again, we can show the movement of these electrons, and it's going to be exactly the same in that regard as A was. So a new bond will form, this bond will move, the electrons of this bond will also go to form a new sigma bond. And so once again, our product is going to be a six-membered ring. So six-membered ring, just as A was. So there's our six-membered ring. We will have two nitriles here from the dienophile. In the starting material, we will have that double bond that is in the product. I'm just going to move this over a little so it's not so crowded. And so now the difference here, we had an EZ diene to start with. And so these methyl groups that remain in the product need to be trans to one another. They did not have the same relationship in the starting material, so they cannot have the same relationship in the product. So there they are. They're trans to one another. And of course, as we've seen before, we will also get the enantiomer, so the other possible molecule where they are also trans to each other, but with the opposite stereochemistries. And so that is the answer to Chapter 27, problem number 14.